Okay, good day. This is Mrs. Tole. So today we are looking at financial maths, grade 10 financial maths, and we need to understand what is interest. So interest is the money paid for the use of money, lent, or borrowed. So if you borrow money, let's say you borrow money from the bank, when you return the money, you'll be charged for that. So for every what you call money that you borrow, you'll be charged what you call an interest. Now, and also it means that when you return the money, it will be an increased amount. So let's say you borrowed what you call 20,000. When you return the money, you might find depending on the agreement, you might return total of maybe 30,000. Okay. Then when you also lend money, what is it? When you lend money, like if you put money in the bank in your savings account, the money can also grow towards maybe you want to save that money for varsity. That money will also earn interest in the bank because the bank will be using the money. Okay. Now, so we have two different types of interest. Interest can be calculated as simple interest or as compound interest. So your simple interest is calculated only on the money invested or borrowed, called principal amount, capital, or present value. So this is the same name. So it means the same thing here. It means the same thing. So the starting amount we refer to as principal amount or capital or also present value, because that's the amount that we have at that moment. Now, so we are saying when you're being charged interest, your interest every year, if you are to return it, if it's charged per year, it means that every year the interest is calculated on the money that you borrowed. Okay. Then compound interest is calculated on the principal amount and the interest that is added to the principal amount at regular time intervals. So let me just go into detail here. Let's give an example here so that you can understand better. 5,000 is deposited into savings account at a bank for 3 years at an interest of 15% per annum. So we will actually see this PA means per annum. Per annum means per year. Okay, it means per year. Okay, then we are saying calculate the value of the investment. Now we're saying you are investing this money, want to see how much is it now after 3 years. Okay, now for first one, I just have to break it down so that you can understand what we mean by what you call when we say interest calculated on the principal amount. So what we have here is that we are saying 5,000 plus your interest 15%, which is supposed to be 15 over 100, and 15 over 100 gives us 0.15. Okay, then we are saying it's 0.15, which is 15% times 15% of 5,000. Then what do we get here? We get 5,750. So first year, you are going to pay 5,000. Your money will be 5,750, meaning to say you have gained an interest of what? Of 750. And that 750 is calculated on the principal amount, which is 5,000. Now, the second year again, you'll see that we are adding that 5,750, then we add an interest, and the interest is still the same. Can you see that? It's still the same. It's still 750. Then we move on again to third year. Interest is still the same. And we are saying 0.15 times 5,000 all the way. And we are seeing that interest doesn't change. That's what we mean when we're saying, interest is charged on the principal amount. But let's compare with compound interest. Compound interest, let's see here what we have here. First year, yes, we are using this value, which is 5,000. Then we have the same interest, same interest, which is 750. But the second year now, what we're doing here, we are charged, the interest is compounding. So interest here is charged on the, on the previous, accumulated amount, which is 5,750. So you find that your interest now, we're saying 0.15 times 5,750, which you obtained in the first year. So you see that your amount will actually differ then your interest differs as you see your interest is growing. Your interest is growing because your money is growing. That's what it means here. So interest is being charged on the previous amount, which is your principal plus interest. So for this example, 5,750 is actually your principal plus the interest, which is 750. Okay, the same applies here. Is still the money that is the added interest and also this interest. So that's what we are saying here. But now let's see how we can find this. How can we calculate this? This work? Using the formulas, simple interest formula and compound interest formula. So just to take you back, this you see that it have accumulated to 7,250. This have accumulated to 7,650, 705, sorry, 605, 7,605. So you find that this is actually more than article compared to the one in simple interest. But let's see the formula that we have here. A is equal to P 1 plus I, which is your interest, and N times N. So that's your simple interest formula. Then compound interest formula is A is equal to P, which is a principal. So A is accumulated amount, P is a principal amount, plus 1 plus I, which is the interest, to the power of N. So that's what we have here. That's what we have, the formulas. Sorry. The formulas that what we have here, we see accumulated amount, which is a future value, which is your A, and P is representing principal amount, which is your present value. Then I is your interest, then N is your number of years. Then N in this case here, we are saying is time period, but it's still number of years. But you understand the difference now when you're talking of when you're dealing with simple interest, when you're dealing also with compound interest, because you might find that your N can be number of weeks, your N can be number of months, your N can be number of number of 6 months, like intervals in a year. Now I want to calculate these values and see if we can still get the same value. Now what we say, A is equal to, what is our P here? P is 5,000. So we take out 5,000 here. Then 1 plus, what is our I is 0.15 times what? What is our N is 3. Now let's see what we can, if we can get the same answer. Okay. Now let's punch this and see 5,000 in bracket 1 plus 0.15 times 3. Then we can close the bracket, and you see that we still get the same answer. Okay, we still get the same answer, which is 7,250. Okay, then let's move on to the next one. It's A is equals to P, and this is for compound interest. Now what is our P? Is 5,000. Then what is our interest? 0.15. What is our N? To the power of 3. Then let's put it here and see what we can get here. Then we're going to say 5,000 in bracket 1 plus 0.15. We close the bracket. This is what we punch to the power of which is the power of 3. Let's see what we get there. We get 7,600. What is it? 7,604. Okay, 7,604. And I want you to understand something here. The reason why we're getting this amount here is that the difference here that we have here is because of what is it? It's because of we were rounding off here. Our answers, we were rounding off. But if we're not rounding off the answers here, like this one here, if we're not rounding off, it means that we're still gonna get the same answer. Okay, so it's actually the thing of what we call rounding off that could have affected our answer. But you can see that it's still one and the same thing. Okay, now let's move on to the next page. We are saying we want to calculate this. We want to now apply this what we call these formulas. We are saying 20,000 is invested for 15 years at 90% per annum. Calculate the value of investments as 1, simple interest, and B, compound interest. Now, we are saying here, what do we have here? We know that our A, which is capital letter, is the one in question. Okay, what is our B? Our P, sorry. Our P is principal amount, 20,000. What is our I? Our I is 9%, which is 9 over 100. What is our N? Our N is equal to 15. Now let's say simple interest. Simple interest, we know that A is equals to P in a bracket 1 plus I N. Then what is our P there? 20,000. 1 plus, what is our I? 9 over 100 times what? What is our N? It's 15 over 1. Then we can close the bracket there. Then you want to see what we get there. What do we get there? We can put equal there. 20,000 bracket 1 plus, we are saying it's 9 over 100 times 15 over 1. Okay, then we can close the bracket. Then what do we get there? We see that we get 47,000. So let me just put the unit here, 47,000 rand. Okay, that's what we have here. Let's see what we have with in terms of compound interest. We already mentioned what we have here, so we're going to say A is equals to P1 plus your I to the power of n. What is our P? 20,000. 1 plus what is our I? 9 over 100 to the power of what? 15. That is our n. Then let's see what we get there. 20,000 in bracket 1 plus 9 over 100. What do we get there? To the power of 15, we get what? We get 72,000. 72,849.65. So that's the amount that we get there. That's the amount that we get. So you can see that with compound, it actually yield more money than your simple interest, isn't it? That's what we have there. Then let's move on to the next question. Temba wants to deposit a sum of money into the savings account so that he will have 30,000 in 3 years' time for an overseas holiday. How much money must he deposit into the account if the interest paid on the savings is 8.5% per annum? Now, can you see what we're having here? Do we have the A? We have A already. Because Temba need 30,000 in future, in 3 years, need 30,000 for the vacation. 30,000. So our A is given. What about our P? Our P is the one in question. That's what we want to know. How much must he deposit now so that he can have that amount of money, what you call it, in 3 years? Now let's have our I. Our I is 8.5 over 100. A percentage is over 100. Then what is our N? Our N is equal to 3. That's what we have there. So we want to know what will we get there? Now we are depositing savings account, interest paid on the savings. Is 18%, 8.5% per annum. So we can calculate using both simple interest. So let's have with simple interest here. A is equals to P in bracket 1 plus I N. Okay. So what it means here, you can, if you don't want to stress yourself, we want to make P up with the formula because that's what we want. So P, we divide both sides by 1 plus I N. So P is going to be equals to A over 1 plus I N. Then what is our A? Our A is 30,000. 1 plus, what is our I? Is 8.5 over 100 times what? 3. Then what do we get? We want to see what we get there. 30,000. Then we put the bracket. Don't forget that. 1 plus 8.5 over 100 times 3. Close the bracket. Then what do we get there? You need to put in 23,904.38 rand. So that's what the amount that you need to put into the bank now. That's what you need to invest. So let's move on here and see with the compound. Now compound is what? A is equals to P in a bracket 1 plus I to the power of N. So again here we know that the P, we divide both sides by this. So we're gonna say P is gonna be equals to A over 1 plus I to the power of N, which is gonna be what? Which is gonna be, what is our A? 30,000. Then 1 plus, what is our I? 8.5 over 100. What is our N? Is 3. Then let's see what we need to have here. So we are saying 30,000. 1 plus 8.5 over 100. We close there to the power of 3. What do we get there? We get 23,487. So 23,487. 87.24 rand. Okay, don't forget to put the unit. That's what we get there. Okay, so that's how you get your answer when you want to calculate what we call the principal value. Let's move on to the next question. We're told that 1,000 rand is deposited in a savings account, and 2 years later, 2,000 is added to the savings. The interest is 11.5% per annum, compounded annually. Now calculate the amount of money accumulated in the account at the end of 5 years. So understand something here. What do we have here is that we can draw what we call a timeline. We are saying is T0 there. Now at T0 here, what did we deposit? 1,000 rand. Okay, now what about 2 years later? 2 years later, it means that T2, so we've got 1, T2. Now at T2, what did we put here? We put what? How much? We put 2,000 rand. Then we want to know now, T3, T4. Now we want to know now how much is it now? What is it? What is it for the whole time or 5 years? So what we have here is our I, which is equals to 11.5%. That's our I there. Then what we are saying here is that here is very easy here what to do. You can first the easiest way that you can do is that you know that your 1,000 is going to grow for 5 years. Your 2,000 is going to grow for 3 years. So this one here, you've got 3 years to grow. So N for this one is 3. Then for 1,000, it's 5 years. So that's what you can see there. Because we are saying this amount, we have added 2,000. So we are adding it, and that 2,000 is going to grow separately as well. But it's still together. But remember, your 1,000 was still there, and it still grows like that. Or what you can do, you can say when you see how much it will grow from what is it from for 2 years, the 1,000. Then from there you add it to the 2,000. Then you complete for the remaining 3 years. So let's start here and see what I'm saying here. So let's start with the method 1. Where what you're going to do, we know that A is equals to what? P1 plus I to the power of N. So what we're going to do here, we're going to add the 2, say 1,000. A is equal to 1,000, 1 plus what is our I? 11.5 over 100 to the power of what? For 1,000 is for it's 5 years, the power of 5 plus 2,000, 1 plus 11.5 over 100 to the power of what? 3, because remember it grows for 3 years here because it was added 2 years after. Then what do we have here? We are adding that. Then when we add there, what do we get? We say 1,000, 1 plus 11.5 over 100 times, the power of 5 plus 2,000, 1 plus 11.5 over 100 to the power of 3. Then what do we get there? We get 4,495.75. This is rands. Okay, now let's see the method 2. What I'm saying here, we are saying what you do here, you grow the what? You grow the 1,000 for 2 years. So it's gonna be 1,000, 1 plus I, which is 11.5 over 100 to the power of 2. And when I see what we get there, 1,000 and bracket 1 plus, what is our I? 11.5 over 100. We close there to the power of what? To the power of 2. What do we get? We get 1,000. So now what we get here is that we get 1,243.225. Now what we have here is we now need to add it to a 2000 because remember it have grown for 2 years, and before we add the 2000 rand, we want to add it here so that we know how much is it now in total plus 2000. So you're gonna say plus 2000. Then what do we get there? We get 3,243,225. So this becomes our principal man. This becomes our principal now, principal amount now for after 2 years. Our principal first was 1,000. Now our principal now is this. So what are we going to do now? We're going to say your A again is going to be equal to your this amount here, 3,243,225 in bracket 1 plus 11,5 over 100 to the power of what? The power of 3, because it's going to grow for the remaining 3 years. Okay. Then what do we get there? Oh, let me just put it so that you don't get confused here. 3,243,225 in bracket 1 plus 11,5 over 100. What do we get there? To the power of 3. Then what do we get there? We get 4,495,75. That's what we see there. So this is the same answers that we have seen. Same answers. So you can use either method to get to what you call to your answer. Okay. So let's see the next slide and see what we have there. Now we are saying calculating interest rates. Now calculating interest rates. Now you're saying 50,000 is invested for 5 years by buying shares in a business. The business was very successful, and at the end of 5 years, the shares were sold for 120,000. Now, calculate a simple interest rate that would yield the same return. Now, we are saying here, what are we having here? We are having A, 120,000. This money have accumulated. P, we are given 50,000. Then what do we need now? What are we also given? N is 5 years. Then what is our I is the one in question. So you're looking for I now in this case, but we know that our formula is what? A is equals to P 1 plus I N, like this. Now I want to see how would we get to what called to your I there? How would we get to your I? We see that if what you're going to do first here, we can put our values here. 120,000 is equals to 50,000. 1 plus your I. What is your I? Is we are looking for I. Then what about N is 5I, like that. Now what you are going to do first is we're gonna divide by 50,000 both sides, because we want to get rid of this now first. So what are we going to get there? We're gonna say 120,000 divided by 50,000. What do we get? We get 0.24. We write it like that. 0, oh, there's something wrong here. It can be 0. This is a big number here. 120,000. I forgot to put the other value there. It's gonna be 2.4. 2.4. Okay. 2.4 is equal to 1. We can now remove the bracket because we already removed the 1 plus 5 your I. Okay. Then what do we do now from there? We take the 1 that side. It's going to be 2.4 minus 1. 2.4 minus 1 is equals to 5I. What is 2.4 minus 1? 2.4 minus 1. We get 3.4. Oh, we get 1.4. Sorry. 1.4 is equals to what? 5I. Then we divide both sides by 5. To get rid of the 5 here, then what do we do here? Let's move on to that. Then we're going to say your I is going to be equals to 1.4 divided by 5. What do we get? This one here divided by 5, we get 0.28. Now 0.28, it means what? It means 28%, because what is it? 0.28, that's your 28%. We're just gonna say it's gonna be equal to 0.28 times 100. Then we can get 28%. So this is 28%. That's our I. That's how we get our I. Let's move on to the next one. Calculate the compound interest rate that would provide the same return. So we are still having the same values. We are still going to use the same values here. That's what we have. So we're going to say A for compound. It's A is equals to P1 plus I to the power of what? To the power of N. And our N, we have it. Our P, we have it. Everything, we have it. Now we're going to say 120,000 again is equals to 50,000. 1 plus, what is our I, is what we're looking for. N is 5. Then what do we do here now? We divide again. We divide, because we want to get rid of P first, which is 50,000. Get rid of 50,000 first, guys. Don't forget that. Then we cancel there. When we cancel, we get the same answer that we got here, 2,4. So 2,4 is going to be equal to what? 1 plus your I to the power of 5. Okay. Now, when we have this, now, how do we now remove the 5 here? How do we remove the 5? That's the question. So I hope you guys, I want you to understand something here. I'm going to do it here. Okay. So if you have got A to the power N, let's say X, sorry, X to the power N is equals to B. Now, to remove this N, what we need to understand here is that we're going to say to the power of what? 1 over N, to the power of 1 over N. And if you did your exponents and you understand your exponents, you find that this one here, you have to cancel it, because we are saying it's F to the power N times 1 over N, which is going to cancel. But what we have here is that when we have got B to the power of 1 over N, this is the same as we put the root sign, or then you put the B, then we have our N there. That's what it means. Okay. That's what it means. So like if we are saying root B in general, there is a 2 there that we don't write. If it's just a root, then it means that is B to the power 1 over 2. So what it means is when you're removing the N there, what must you do? You must put it on the root here. I hope you understand, guys. So if it is X to the power 5 is equals to 32, what we are simply saying, just X is going to be equals to, we put the root 32, then we put the 5 there. You understand? Then that's how we remove it. Then we're going to say, what is it? We put it, when you are writing it here now, what do we need to do now? We are going to say shift, then you put that, then you put 5, and you put inside, you put 32, then we get our 2. So your answer will be 2 in this case. So let's go back to the question again and see what we are saying here. So it means that here we're going to say 1 plus I, we want to remove the 5, is going to be equals to 2,4. We put our 5 there. Okay. Then what do we get there? We're going to say shift root 5, 2,4. Then what do we get? We get 1,19. So we're going to say, what is it? It's going to be 1, so it's going to be 1 plus your I is going to be 1,1914. Okay, then we take the 1 that side, it's going to subtract. So we're going to say I is going to be equals to 1,1914 minus 1. Then what do we get there? Minus 1. What do we get? We get I is going to be equals to 0,19. Now 0,19, that's what we get there, 0,19. It means that our I is going to be equal to 0,19 times what? 100 to become a percent. Then it's going to be 19%. That's what we are having here. So these are our answers. That's what we have. We'll get 19%, and this one will be, it will be 28%. It won't be the same because remember, interest, simple interest and compound interest, they actually totally different. Okay, that's what we are getting here. Okay, let's move on to the last part here, which is about loan. So remember, when you borrow loan, when you borrow money, you have to return it. Okay. So there's no way you can borrow money, then you can't return that money. So we need to understand now, how does it work? Now, when you're saying interest of the loan can be calculated on reducing balance or a simple interest. But what you're going to understand at your level now for now is that you need to understand the simple interest. And the one on simple interest is what we call hire purchase. So hire purchase. So the grade 11, that's what you're going to do, reducing balance and everything. But now we are saying hire purchase. That's what we focus on. So whenever you see hire purchase, you think of simple interest. Okay. Now let's see here. Lebo buys a washing machine for 9,200. He pays 15% on in cash, and the balance is paid through a hire purchase loan, a loan agreement over 36 months with an interest rate of 15% per annum, simple interest over 3 years. Now, calculate Lebo's monthly repayments. Want to see how much does she have to pay every month. Okay, so here when I read again, Lebo buys a washing machine for 9,200. So this is what we have. He pays 15% in cash, and the balance is paid through hire purchase loan agreement over 36 months. That's what we are saying. And with an interest rate of what? Of 15% per annum, simple interest. So what we're going to do first here, we're going to say, we are saying we have got paid. This is a more like you paid in advance the 15%. So we're not going to include it for now. So we're going to say 9,200 minus that 15%. We want to see how much now was left. Because now we're trying to calculate how much did she pay? Because she pays 15%. What is that 15%? Okay, 9,200 minus the 15%, because she didn't borrow 9,200. She borrowed minus 15% of the 9,200. Then we want to see how much did she borrow. So she borrowed 7,820. But this 7,820, it had to grow. It has to grow, and when it grew on a simple interest rate over how long? Over over 3 years. So we're going to say A is equals to P1 plus IN. Then what is our P? Our P is 7,820. 1 plus, what is our I? Our I is 15 over 100. Then times what? What is our N? Is 3. So when I see how much there is it in total, 7,820. We put a bracket, 1 plus 15 over 100 times 3. Then we close the bracket. What do we get there? We get 11,339. And 11,339, this has to be paid over how long? Over 3 years, 36 months. So we want to see how much money does she pay monthly. So we're going to say, what is it? That monthly repayment is going to be 11,339 divided by 36 months. That's what it means there. Then what are we going to do? We're going to divide it by 36. Then we see how much does she have to pay every month. So we find that she's going to have to pay 314.97 cents. That's what it means here. So this is how you calculate, guys. Remember, you need to calculate the total amount first. Then what is it? Then you see how much she has to pay every month. Now let's move on to B. This is our A. Calculate the total amount of money paid over 3 years. Now, total amount of money paid over 3 years. What we're going to do now is, we know that total amount. Okay. So we are saying total amount here. We are going to say is going to be the amount that she paid, which is the 15% in cash. This amount that she paid, the 15% in cash, plus the accumulated amount here. That's what we have here, the 11,000. So we're going to say is going to be equal to 11,339 339, the amount that you've accumulated, plus the 15% times what? 9,200. Because we want to know how much now because she paid this money in advance, but she also paid later on a accumulated amount of 11,339. So we want to see now how much did she pay now in total. We're going to say 15 over 100. We just want to see how much was it, the 15% times 9,200. Then what do we get there? So we see that it's 11,339 plus 1,380. That's what she paid cash. Then what do we get there? Plus 11,339. Then we get 12,719. That's how we get the total. That's how we get the total amount that she had to pay. Don't forget that she paid earlier on. So it might be confusing. Why are they asking me this? Because I've already calculated the 11,339. No, it's not only the amount that she paid. She also paid the 15% in the beginning. Okay. Now calculate how much extra Lebu paid. So we are saying it's C. Now, how much extra Lebu paid? We are going to say now the machine costed how much? 9,200. 9,200, but she had to pay how much? 12,719. So we just want to see how much now did she pay what you call what is it, extra. So we are saying, we're going to say here the cost of extra is going to be equals to what? Accumulated amount minus the cost, initial cost. So here, the formula doesn't matter here, just for you to understand, but you don't need to write the formula, it doesn't matter there. It's going to be 12,719 minus 9,200. Minus 9,200, we already had it. So she had to pay extra of 3,519. Okay, so guys, when you're dealing with this, don't forget to write units. Don't forget to put the units, guys. Don't forget, please. When you're writing, you are not just going to write 3,519. Are those goats or what? Are those cars? Are those people? We need to know that it's money and it's in rands. Okay, thank you so much. I hope you guys understand. Thank you so much.